Friction, definitions and key points. Friction force. Friction force is the resistance to motion when an object moves across a surface or through a medium such as air or water. It is essential for everyday activities like walking, running, and the movement of vehicles. Static friction force. S. This force acts on an object at rest, preventing it from moving. It increases with the applied force until reaching a maximum value, given by F text max equals μn, where μs the static friction coefficient, which depends on the surfaces in contact. N is the normal force, the perpendicular force exerted by a surface on the object. Kinetic frictional force. Once the applied force exceeds the maximum static friction, the object starts moving and friction transitions to kinetic friction. This force remains relatively constant at small velocities and is given by Fk equals μkn, where μk is the coefficient of kinetic friction, typically lower than μs. N is the normal force. Normal force N, the force exerted perpendicular to a surface when an object is in contact with it. It plays a crucial role in determining both static and kinetic friction. Friction coefficient, E, a dimensionless value that depends on the materials in contact. It does not depend on the contact area. Key points. Friction can be beneficial, e.g. providing traction for walking and driving, or harmful, e.g. causing wear on machine parts. Friction always acts in the opposite direction of motion, or the attempted motion in the case of static friction. Both static and kinetic friction are essential in understanding motion mechanics, influencing transportation, engineering and material design. Step 1. Define friction force and explain its role in everyday life. Provide specific examples of activities where friction is essential. Friction force is the resistance that occurs when one surface moves against another. It is crucial in everyday life because it enables various activities. For example, friction allows us to walk without slipping, as our shoes grip the ground. In driving, friction between the tires and the road surface enables acceleration, braking, and steering. Additionally, friction is essential when using tools such as a hammer hitting a nail, where it helps to secure the nail in place. 2. Describe the differences between static friction force and kinetic frictional force in terms of their definitions, behavior, and effects on an object in motion. 2. Describe the differences between static friction force and kinetic frictional force in terms of their definitions, behavior, and effects on an object in motion. Static friction force acts on an object that is not in motion, preventing it from moving when a force is applied. Its magnitude can vary up to a maximum value, which is determined by the static friction coefficient and the normal force. In contrast, kinetic frictional force acts on an object that is already in motion. It is generally lower than the maximum static friction and remains relatively constant at small velocities. The behavior of static friction allows for a range of resistance, while kinetic friction provides a consistent level of resistance once movement begins. 3. Explain how the normal force impacts the static friction force experienced by an object. What happens when the normal force changes? The normal force N is the perpendicular force exerted by a surface on an object in contact with it. The static friction force is directly proportional to the normal force, expressed as Fx max equals μsn. When the normal force increases, the maximum static friction force also increases, allowing for greater resistance to motion. Conversely, if the normal force decreases, the maximum static friction force decreases, making it easier for the object to move when a force is applied. 4. Discuss the significance of the static friction coefficient, μs. How does it affect the maximum static friction force? The static friction coefficient μs is a measure of how much frictional force can exist between two surfaces before they start to slide relative to each other. It is a dimensionless value that varies based on the materials in contact. A higher μs indicates greater resistance to motion, leading to a higher maximum static friction force, while a lower μs suggests less resistance. This coefficient is significant for determining how much force can be applied to an object before it begins to move, which is critical in applications like construction and transportation. 5. Analyze how the kinetic frictional force varies when an object is set into motion. What factors can lead to changes in this force? The kinetic frictional force, K, is typically constant for a given set of materials and conditions, expressed as Fk equals mu Kn. However, it can vary with several factors, including the speed of the object, the nature of the surfaces in contact, and the presence of lubricants. For instance, as the speed of an object increases, the kinetic friction may remain relatively constant up to a point, but at very high speeds it can change due to factors like heat generation or changes in surface characteristics. 6. Explore the relationship between the normal force and the kinetic frictional force. How does this relationship manifest in real-world scenarios? The kinetic frictional force is directly proportional to the normal force, described by the equation Fk equals mu Kn. This means that as the normal force increases, the kinetic frictional force also increases. In real-world scenarios, this relationship is evident in vehicles. For example, a heavier vehicle will exert a greater normal force on the road, resulting in a higher kinetic friction force during motion. This increased friction helps with traction, allowing the vehicle to accelerate and brake effectively. 7. Evaluate the importance of understanding friction coefficients in engineering and design. How can this knowledge improve safety and efficiency? Understanding friction coefficients is essential in engineering and design because it influences material selection, surface treatments, and overall performance in various applications. Knowledge of friction coefficients can improve safety by ensuring that surfaces provide adequate traction, reducing the risk of slips and accidents. In machinery, optimizing friction can enhance efficiency by minimizing energy loss due to unwanted frictional forces, leading to better performance and longer equipment life. 8. Discuss the factors that affect the friction coefficient between two surfaces. How do these factors influence the performance of machines or vehicles? Several factors affect the friction coefficient, including the materials of the surfaces, their roughness, the presence of contaminants like oil or dirt, and environmental conditions such as temperature and humidity. For machines and vehicles, these factors influence performance significantly. For instance, a high friction coefficient between the tires and the road enhances vehicle control, while low friction in machinery components can lead to wear and energy inefficiency. Understanding these factors helps in designing safer and more effective systems. 9. Compare and contrast the effects of surface roughness on static and kinetic friction. How does this property influence material selection in applications? Surface roughness affects both static and kinetic friction, but in different ways. Rougher surfaces tend to increase both static and kinetic friction due to more significant interlocking between the surfaces. However, the increase in static friction may be more pronounced because it has to overcome the initial resistance. In material selection, engineers must consider the application requirements. For example, a high-friction surface may be desirable in tire design, while smoother surfaces might be needed in bearings to reduce wear and energy loss. C10. Reflect on a situation where insufficient friction leads to failure or safety hazards. What can be done to mitigate such risks in practical applications? An example of insufficient friction leading to safety hazards is during wet or icy conditions, when vehicles may skid due to reduced tire traction. This can result in accidents and injuries. To mitigate such risks, measures can be taken, such as using tires designed specifically for wet or icy conditions, applying sand or salt to icy roads, and improving road drainage to reduce water accumulation. Additionally, incorporating advanced traction control systems in vehicles can enhance safety by adjusting the power delivered to the wheels based on the available friction.